So we're going to continue this, but you'll notice, this is in log form, it's not in exponential form, but I want to remind you, if exponential goes like this, we know that logarithmic, or log, goes like this. Okay? And if you're doing the parent function, you'll see it goes like this. So what does that mean for the first one? That means this isn't the parent function. The parent function of this would be log 6x. So if that's the case, what is the transformation for this one? That means that is a horizontal translation, 6 left, not a straight shooter. So that means this is now going to go 6 to the left. And then this straight shooter, vertical translation, up 2. So now it's not only going to go to the left, but it's going to go up 2. Okay? Now, let's see. Can we pick any number for x? Remember how before when we were in exponential form, I was like, hey, you can pick any number you want. But remember what I said about exponential form and logarithmic form. What did I say? They are inverses of each other. Well, if they're inverses of each other, and the domain here is all real numbers, does that mean the domain here is all real numbers? No. That means the range is all real numbers. And if I said in the other one that y is greater than 0, what does that mean the domain's got to be? Greater than 0, unless there are transformations. Now some of you go, okay, I get that, but I still don't know then, what does that mean? Does that mean that I should pick, like if I'm doing a table, should I pick 0, 1, 2, 3? Well, yeah, maybe, but then the hard part's going to be, well, if I put in 0, and then I subtract 2 and change it to exponential form, that might be kind of a pain. So let's start off with being a little bit logical, and let's look here. Okay? It's very interesting. Let's look here. So that's negative 5.999, which means, could x equal negative 6? It can't. It's going to approach negative 6, but it never quite, well, actually, yes, it can. Sorry. No, it doesn't. Okay? Because look, what does it say when it's negative 6? It's undefined. So now we have something called an asymptote, and I'm going to put that in pink. X is never going to quite cross negative 6. It's changing a little bit. And then if you look here, look at that. Okay, so that's the y value of 3. And then now we can go higher and higher and higher. Now it's going higher and, oh, I'm sorry, you can't see that. It's going higher and higher, but very, very slowly, isn't it? It's just really slowly. Okay, so if we're doing this problem, should I pick negative 6? Well, if I pick negative 6, we just saw that it's undefined. Okay? If I'm going to fake it, I can fake it, right? Let's look here. There is a y-intercept. What's that y-intercept? 0, 3. So I do know that 0, 3 works. Okay? And I think I'm okay with that. And then now let's graph it, show that it's going up, and it's going to slowly go there. Okay? What's more important? And I'm okay with that being enough, all right? And then now let's do the domain and the range. Can the domain be any number? No, we saw that it has to be bigger than negative 6, which means negative 6, positive infinity. Now the range, it could be any number. It's going really slowly, but it could be any number. Because remember, when we're dealing with exponential form and logarithmic form, they are inverses of each other. Okay? So I'll do one more, and then you can just do the rest for homework. All right, so let's do number 21. I'm going to pause it really quickly so I can graph it. One sec. Or actually, you know what? I'm going to show you how to graph it here, because I want to make sure you know how to graph without me. So it's going to take a second. So let me zoom in a little bit. All right. So I'm going to go log. Do you notice how it says base 6? So what you're going to do is you're going to go to the Functions button and go to Miscellaneous. If you look, there's a log and a log with a little a. If I tell you the base, then you need this one. If I don't tell you the base, then it's going to be base 10, and you won't need to put any base, so you can just use that. So y equals, and let's go back here, so it says log 6, and then now I just go x minus 1, and I go minus 2. Okay, so we look, it moved, all right? If I was talking about the transformations, I would say it's a horizontal translation, 1 to the right, not a straight shooter. And look at that, it does look like it went to the right, doesn't it? Okay, and this is a vertical translation, 2 down. All right, so if I'm going to follow this, and this was plus 6, so that negative 6 went down. So that means if that's 1 right, I'm going to have to go like that, and that's called the asymptote. Okay, and then now let's use this to help us. Okay, so I don't have a y-intercept, do I? Because look at this, did you notice? Look at it, even stopped because it's saying you can't do it. So if I did my table and I put in -1, -1 is undefined, okay? And I don't even think you're going to get to a 0, are you? Oh, there we go, I found it. You can't see it there? It's at 37. So 37, 0. I'm going to fake it, okay? So we'll just say that's 37. Now I go like this. Oops, and I missed it, but you get it. What's the domain? X has got to be greater than -1. -1, positive infinity. The range, it could be any number, all real numbers, -infinity, positive infinity. Okay? Your homework will be to do the other ones. Use Desmos to help you. Okay? Let's turn the page. You've done this already, but I need to make sure you're solid on it. I'm going to only do some of them because there aren't very many, and then you'll do the rest. So it asks you to change it to rad form. Remember, if you have a fraction, that's what goes in there. That is, if I was to write this, this is the cube root. Let me zoom out a little bit. Cube root of 8. Now, if I was to rewrite this, I could rewrite this as 2 cubed to the 1/3, which is 2 to the 1st, and 2 to the 1st is 2. So if you can't simplify it, I need you to simplify it. If you can't simplify it, then you won't. Okay? I'll do one more. I'll do number 1. This is the same thing as the square root of 6. I could put the 2, but I don't feel like it. Now, can I do anything with that? Nope. So that is my answer. You'll do the rest. It won't take very long. Now, this one, they want you to put it in exponential form and then simplify it. Excuse me. So what I will do is I'll do number 9. So that would be 9 to the 1/3. And I go, I don't know, can I simplify it? Well, I do know that 9 is the same thing as 3 squared. And 3 squared to the 1/3 is 3 to the 2/3. So that's the most I can simplify it. And some of you go, it looks a lot prettier like this. I understand. But in exponential form, this is what we put. Okay? Let's do one more. Let's do number 12. So this means 8 to the 1/2. But that's really 2 cubed to the 1/2, which is 2 to the 3/2, which is really 2 to the 2/2 and 2 to the 1/2. Just give me a second and I'll explain it. Okay? And 2 over 2 is 2 to the 1st times 2 to the 1/2, which is really 2 times 2 to the 1/2, which is 2 square root of 2. I wanted you to see how that kind of went. And some of you go, what? Miss Rifkin, I could just birthday cake it. I understand. I just want to show you what things mean. There's my 2. And there's my rad 2. But I want you to see how in exponential form I did the same thing. It might be easier to just do it that way, isn't it? Okay? Now, some of you go, well, what if I had to do the cube root of 8? I just want to show you this. Could I still birthday cake it? Yes, I could. 2, 4, 2, 2, 2, 1. This time, though, instead of circling doubles, I circle triples. So the answer would be 2. And that's true. The cube root of 8 is 2. Let me do one more. If I had to do the 5th root of 64, I could be obnoxious and do it this way, or I could birthday cake it. 232, 216, 28, 24, 22, 21. Now if it's the 5th root, what do I need to find? A group of 5. 1, 2, 3, 4, 5. Which gives me 2. And then now what am I left with? The 2. But don't forget the 5th root. You'll finish the page. That's your homework.